Hello everyone. In today's video, we are looking at some useful shortcuts in adding up the terms of both finite and infinite series. The first one is a finite series like this. 1 divided by 3 multiplied by 5 plus 1 divided by 5 multiplied by 7 goes all the way up to 1 divided by 11 multiplied by 13. Before applying the simplification technique to be discussed here, there is one important point to be confirmed about the given series. That is this. Look at the denominator of the first term, 3 multiplied by 5. And what is the difference between these two terms? That's 2. Similarly, 5 multiplied by 7, the difference is 7 minus 5, 2. If you look at all the denominators of the given series, the difference between the two terms remains the same. By the way, the difference doesn't have to be 2. It could be any number, say 3, 4, whatever, but the difference should be maintained in all the terms. That's all. First, I will give you the shortcut, which you can do in just a few seconds. Then I will take you through the longer method, which will give you the logical explanation for the shortcut used here. So first, the shortcut. In the shortcut, what we do is count the number of terms. How many terms are there? 5. You write that 5 first. Then divide it by. Look at the first term. You can see 3 here. Write that 3 here. Then look at the last term. 13 here. You write that 13. This is the final answer. This sounds simplifying. 5 divided by 39. So what is the shortcut? You write the number of terms, which is 5. Then divide it by the first number in the denominator of the first term, that is 3. Then the second number of the last term in the denominator, which is 13. That's all. Now I will take you through the longer approach for the summation of this finite series. In the first step, write the first term as the difference of two fractions like this. This on simplifying you get 3 multiplied by 5, 5 minus 3, which equals 2 divided by 3 multiplied by 5. So this is equal to this. Now take 2 to the left side. 1 by 2, 1 over 3 minus 1 over 5 equals 1 over 3 multiplied by 5. Now look at this 1 over 3 multiplied by 5, which is the first term of the given series to be simplified. And that you have written in this form. Now take the second term. Using the same logic, we can write it like this. 1 over 5 minus 1 over 7 equals 2 divided by 5 multiplied by 7. Then taking 2 to the left side, let me write it here. You have 1 over 5 minus 1 over 7 equals 1 over this 2 taken to the left side, 5 multiplied by 7. In the same way, you can write every subsequent term of the given series. So the third term on splitting, you have 1 over 7 minus 1 over 9 equals 1 divided by 7 multiplied by 9. And the fourth term, 1 over 9, 1 over 7 equals 1 over 9 multiplied by 11. And the last term would be, sorry, I made a mistake here, 1 over 9, 1 over 11. And the last term will be 1 over 11 minus 1 over 13 equals 1 over 11 multiplied by 13. In the last step, what do? We will just add up these 5 equations. And let me write this first. So adding up 1 over 3 multiplied by 5, 1 over 5 multiplied by 7. And let me write the last term, 11 multiplied by 13. This is the given series to be simplified. And this equals sum of these terms. You can see 1 by 2 being common in all the terms on the left side. Inside, see, there will be many cancellations. Minus 1 over 5 plus 1 over 5. Minus 1 over 7 plus 1 over 7. These two will cancel out. These two, these two, these two. So you are left with 1 over 3. The first term of this splitting minus the last term. Everything else got cancelled out. Let me simplify this again. 1 over 2, 3 multiplied by 13, cross multiplying 13, 3. 13 minus 3, 10. denominator 39. This goes 5 times 5 divided by 39. This is the answer we had in the shortcut. Now to help you get a better understanding on the shortcut applied here, let me do one more problem. Another finite series like this. See, this series has 6 terms. So you write that 6 here. That's the first thing. You got the numerator of the answer, 6. In the previous case, it was 5. Here it is 6. Now take the first term of the finite series to be simplified. That is 1 over 7 multiplied by 10. Write the first number in the denominator, which is 7. Then you go to the last term, which is 1 over 22 multiplied by 25. You take the second term, 25. In the first term, you take the first number. In the last term, you take the second number. That's all. And this is equal to 6 divided by 175. This is the final answer. The shortcut is very simple. It will take just a few seconds to simplify the series. And this on further simplifying, you get 6 divided by 175. There is an important point to be ensured before applying the shortcuts. When you look at the denominators, see what is the difference between these two? 7 and 10, 3. What is the difference between these two? Again 3. If you look at all the denominators, the difference between the two numbers given in the denominator turns out to be the same, which is 3 in this case. And 3 doesn't come into the picture in the shortcut used here, but the difference should be the same. In the previous problem, the difference was 2. Here it is 3. After confirming this important point, you look at the number of terms in the given series, which is 6. That 6 I am writing. First number in the first term and the second number in the last term. That's all. So you have seen how to apply the shortcut for a finite series. Now let me extend this to an infinite series. If you take a series like this, it breaks here. In the infinite series, it will go on to infinity. Okay. Now I'm going to use the second problem we have already discussed. The only difference is it was a finite series before. Here I am extending that series to infinity. Here also I'll show you the shortcut first. Then I'll take you through the longer approach to get a logical explanation for the shortcut used here. Here first you check for the same difference in the denominator. You're getting the same difference. 10 minus 7, 3. 13 minus 10, 3. 16 minus 13, 3. That is the way the series goes on. So in the shortcut, you write 1 divided by 3, where 3 is the common difference you're getting in the denominators. Then you write 1 over 7, where 7 is what? This number. That's all. This is the final answer, 21. See, you can do this just in a second. The infinite series, to get the answer, that the common difference gets reflected in the shortcut. Can you see? 3. Whereas we didn't use this 3 in the finite series. For the infinite series, that number is to be written first. If you want, I'll give you the longer approach also. The procedure is the same. See, you will write this number, each number, as the difference of two numbers. So take the first one. You can write it like this. 1 over 7 minus 1 over 10. That's equal to 7 multiplied by 10. 10 minus 7, which is 3 divided by 7 multiplied by 10. So this is equal to this. Take 3 to the left side. You will have 1 over 3. On the left you have 1 over 7 minus 1 over 10. And on the right, 1 over 7 multiplied by 10. This is the first term in the given series, and that's equal to this. Similarly, using the same strategy, the second term, which is 1 over 10 multiplied by 13, you can write like this. 1 over 10 minus 1 over 13. And the third term, which is 1 over 13 multiplied by 16, this would be 1 over 13 minus 1 over 16. And it goes on to infinity. There's no end to this. Okay. Now, when adding up all these infinite equations and writing this first, the right side will be the given series. So let me write the right side first. This is what you have. 1 over 7 multiplied by 10. Then 1 over 10 multiplied by 13. Then 1 over 13 multiplied by 16 up to infinity equals, if you look at the left side, 1 over 3 is common in all the terms. And look at the terms inside the bracket, they will cancel out each other. This will cancel with this, this will cancel with this will cancel with the subsequent term, and it will go on infinitely. So there's no end to this. So basically, only this will be left over. This one, 1 over 7. And that's equal to 1 over 21. That's all. This is the logical explanation for the shortcut used here. If you think you've learned something to help you do well in the quantitative aptitude, the competitive exams you are going to write, please like, share and subscribe to my channel and hit the bell icon so as to get notified of other similar simplification techniques. Thanks for watching and see you in the next video.